Hello everyone, I'm Yi-Chang Liu.
I'm Yu-Chuan Wang.
I'm Yi-Xian Liao. We are from National Experimental High School at Central Taiwan Science Park. We are going to introduce our project, discussion on measuring phosphorus concentration by self-made detection box. These are all things in our presentation. In the vitamin C calorimetry method, a spectrophotometer is used to measure the absorbance to estimate the phosphorus concentration. But the price of the spectrophotometer is extremely high. Therefore, we want to use a simple materials to create a cheaper but useful phosphorus concentration detection box, hoping it can reach the function of a spectrophotometer. This is our flowchart. Next, we will introduce more about each step. In the first step, we configure the phosphorus solution from 0 to 70 ppm and coloring reagent according to the vitamin C calorimetry method, and then mix them together. Put them in a centrifuged tube. In the second step, after preparing the black cardboard and phosphor sensors, we make the detection box and connect it with a program written by Arduino. This is the construction of our detection box. We use the photo as a light source. Next, we make a space for the cuvettes. Attach the photosensitive sensor behind the cuvette, measuring the light intensity after the light passes through the sample, and the sensor will transmit the data to our computer. Then, we can use the data to figure out the consumption of light intensity. After detection box is done, we measure phosphorus solution absorbance by spectrophotometer and consumption of light intensity by our detection box. Observing the two detecting data, we find the most appropriate detecting range. Moreover, we combine them, conclude the relationship chart and a formula which shows how the data of two is converted. Then, we took river water samples from 4 reaches of the Han River in Taichung to get random phosphorus concentration solutions. The last step, we process the standard phosphorus solution and river water samples according to the vitamin C calorimetry method and test the accuracy of the formula between the detection box and spectrophotometers. Now, we will display a video what we did about the experiment.
First, let us introduce more about the vitamin C calorimetry method. As the picture shows, these are the chemicals used in the experiment and their uses. And this is the course of reaction for the vitamin C calorimetry method. First, phosphate radical will combine with the molybdate radical into phosphomolybdic acid hydrate. Then, it combines with the antimony ions into phosphorus antimony molybdenum blue compound, which contains positive 5 molybdate and makes the solutions turn blue.
This is our self-made detection box. First, we put the cuvette into a space we designed for it and set up the phone as a light source. Second, we regard the pure water as a standard, measuring its light intensity. Then the data will show on the computer screen. This is the Arduino program. We measure the light intensity of each sample, comparing them with the standard data to get the consumption of light intensity.
The chart shows the absorbance of each phosphorus solution. We can see that the data of the x-axis is almost proportional to the one of the y-axis in the range, from 0 to 3.5 ppm. For this range, we find that its correlation coefficient is about 0.995. As a result, we regard that the phosphorus concentration from 0 to 3.5 ppm is the suitable detection range by a spectrophotometer, then creating a formula. And this is the chart showing the relation between the solution of phosphorus concentration from 0 to 70 ppm and the consumption of light intensity. Similarly, we found that the suitable detecting range by our detection box is from 0.5 to 3.5 ppm. Combining the data above, In the range from 0.5 to 3.5 ppm, we establish the relationship between absorbance and consumption of light intensity, and find that its correlation coefficient is up to 0.998. Then creating another formula. We use the results above to come up with a new formula, where we get the data of consumption of light intensity. Substituting the data into this formula, it will show its corresponding phosphorus concentration. We check the formula by taking phosphorus solutions we configure in advance to check out its accuracy. We can see that all data's percentage errors are within 10%. Next, we took river water samples to check. We found that data's percentage errors are under or around 10%. To sum up, our detection box could be used for when detecting phosphorus concentrations in the range of 0.5 to 3.5 ppm. According to the results we got, we consider the idea that creating a detection box as a simple measurement tool is feasible, but the accuracy has yet to be improved. There are some aspects we hope to improve in the future. First, using a stable light source instead of mobile phones due to the differences in light intensity of each phone. Second, we hope to improve the accuracy to within 5% to get closer to the real situation. Third, we hope that the detection range can be expanded in the future. This is all of our presentation. Thank you for listening.